So welcome back to more examples on how we use the discriminant. Right here we have another quadratic equation, x squared plus 6x plus 9 equals 0. Right here is the discriminant. Let's input it straight away. b is 6, 6 squared is 36. Minus 4 times 1, right here a is 1. We don't need to put the a in front of the x squared, as 1 times x squared is just x squared, so that's 1 for the a. Minus 4 times 1 times c is 9 right here. So minus 4 times 1 times 9 is, we will come to negative 36. So negative 36, put down the 36 right here. 36 minus 36, this is equal to 0. So in the very first episode of the discriminant series, we have seen that when a discriminant is equal to 0, then the quadratic equation will only have one root, called a repeated root. So when b squared minus 4ac is equal to 0, then that equation that we have inputted will only have one root, called a repeated root. Let's try and prove that. So using the quadratic formula, negative b, or minus b, negative b, which is negative 6, plus minus the square root of the discriminant, which is b squared minus 4ac, as we have learned a second ago, was 0, over 2 times a, which is 2 times 1. 2 times 1 is just 2. So this is these are our roots, x1 and x2. This is equal to our root. So minus 6 plus minus the square root of 0 is just basically 0. So we can replace this with just 0 over 2. So the first root is negative 6 plus 0, which is just negative 6, over 2 is equal to negative 3, and the second root is when negative 6 minus 0 is still negative 6, over 2, this is still negative 3. So we can see that there is only one type of root, which is negative 3. So when you are to answer what is the root of this quadratic equation, you don't need to write that root 1 is minus 3 and the second root is minus 3 as well. You just need to write that x is equal to minus 3, as it only has one root, and this is a repeated root. Let's look at another example. X squared plus 3x plus 2. Let's input this into the discriminant. B squared, which is 3 squared, 9, minus 4 times a, which is 1, times c, which is 2. Minus 4 times 1 times 2 is negative 8. So 9 minus 8, this is equal to 1. So 1 right here is a perfect square. This is a perfect square. So we have learned that if the discriminant is equal to a perfect square, then we will then this equation will have two roots, and those roots will be integers or fractions. Let us prove this right now using the quadratic formula. Minus b, which is negative 3, plus minus square root of 1 over 2 times a. 2 times 1 is just 2 right here. So let's look at the first root. Is when negative 3 plus square root of 1. Square root of 1 is just 1, so we can just replace this with 1. Negative 3 plus 1 is negative 2 over 2. This is equal to negative 1. The second root is when negative 3 minus 1 equaling to negative 4 over 2. This will result in negative 2. So as we see right here, there are two roots for this quadratic equation, and those roots are integers. And you may see some other quadratic equations which will have fractions inside of them, and when the discriminant equals to a perfect square, you will see them as fractions as well. So, but in this case we have integers for the roots of this quadratic equation.